I've often noticed how people starting with new techniques believe that they will solve a lot more problems than they actually do, and then they get disappointed because they don't. But the nature of software development, particularly when you're dealing with complex problems, with architecture, with software design, is that things are more complex than they seem. And today I'm going to talk about one specific case in point, which is the relationship between domains and bounded contexts in domain-driven design. Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And today I will react to an article written by Mattias Verraes. Once again, great job, Mattias. You are writing excellent articles. And this article is named Know Your Domains and Bounded Contexts Don't Map One-on-One. And for me, this is an interesting case study because this applies to other things as well. So for example, people who expect that by doing test-driven development, they will immediately obtain 0 bugs. Or people who believe that by adopting a specific type of architecture, they can forget about all the challenges of other types of architectures. When in reality, all we have is trade-offs. And we need to understand those trade-offs. And for each technique, we have advantages, strong points, and disadvantages, and an applicability domain. So domain-driven design applies really well wherever we have complex domains. But we need to be very careful not to oversimplify how the domain is mapped to the actual architecture in our code and the actual structure of our code. So let's see what Mattias has to say. This is an article published on 28th August. Bounded contexts are a design choice to suit engineering needs. So very interesting already from the subtitle because it underlines this important thing. Design is not about copying things from real world into software. It's more about picking the right abstractions that match software development. It's a subtle difference, but it's a very important difference. This is why the examples from old books on object-oriented programming, where they took objects from the real world and tried to map them on objects in code, are very interesting in terms of learning, but they are not actually true when you start to do anything more complicated than learning problems. Here's a myth that won't die. Your bounded context should map one-on-one to your business domains. It sounds clean and logical, but it's wrong. The myth persists because sometimes it's true, it could be true in ideal but imaginary circumstances. It absolves you from doing deep modeling and critical thinking about your organization and software systems. Be careful with software design rules that promise a simple one-size-fits-all solution to a complex problem. I'll demonstrate that there are many valid reasons not to map your domains one-on-one to your bounded context. It's unrealistic in non-trivial systems, and it ignores the benefits of bounded context as a software design tool for gaining control and understanding of our domains and systems. So I think that one area where I've seen that bounded contexts align with business domains is when one of the criteria for splitting in bounded contexts is changeability. And it's likely that different areas of your organization change with different speeds, which means that different bounded contexts are likely to map on different areas of your organization. But that is not completely and always true, because it depends a lot on the context. Maybe your software has to deal in depth with one part of the organization and only in a very shallow manner with with other parts. So even if those other parts change with a different speed, because your integration is actually shallow, it means that you might be able to get away with one bounded context for, let's say, 10 departments of your organization and another bounded context for your core problem. So this is where I think these things come into place, and it's important to understand. And this is only when you take into account the structure of the problem, but once you move into solution domain, you might end up with different bounded contexts as well. Because even if ideally you would have one bounded context for one department, let's say sales, okay, you have one bounded context for your sales department. What's really happening is that maybe parts of the sales department require different technical solutions. Maybe you need a different type of database, maybe you need transactional behavior versus non-transactional, and so on. So, or higher security for some parts, lower security, not zero security, but not as much for other parts. So this is why it's very complex and it's very contextual. Your domain model is your own and you should treat it as such, which is why also one size fits all rules don't work. Quick recap. In domain-driven design, a domain is an area of activity, knowledge, and expertise that your organization is active in. For example, you could be in finance with lots of possible subdomains like trading, consumer banking, loans, sales, customer retention, down to accounting and HR. A bounded context is a linguistic and model boundary. Very important. So one of the things that I find software developers resist is the idea that they are working in a humanistic domain. Really, bounded context, if you take the idea of bounded context from domain-driven design and apply it to linguistics, you get something called jargon. A jargon is a set of technical terms that a specific group of people from a specific profession understand. You have medical jargon, you have sales jargon, you have technical, software jargon, and so on. And basically what we are doing when we split in bounded context is identifying jargons that are more precise because they need to fit with our software model. So really, domain-driven design is also a linguistic process. Inside this boundary, we use a single unambiguous language, a jargon, and a single consistent model to talk and reason about the problem. In the code, you should be able to look at all the terms and relationships and behaviors and be able to understand it as a whole. Every term is clearly defined and understood, and adding or removing terms and concepts is very deliberate. Ideally, but not always, the code for a single bounded context is contained in a single deployable unit, but it is out of scope here. So typically, if you're doing microservices, which is probably the most common implementation or most common architectural style for domain-driven design, although not necessarily the best one, what you will have is a microservice per aggregate, and then you could have bounded context kind of split, maybe having 1-2 aggregates. So this is why you don't necessarily have one-to-one relationship. The domains are how the business sees itself. The org chart will often reflect this and structure the company to reflect it. The accounting department manages all the people and resources to deal with the accounting domain. Yeah. So basically what we were talking before. Software disrupted that. Suddenly you have people who are skilled in software engineering disciplines as opposed to the company's domains. They are organized in a separate engineering department, but they bill for the other departments. In other words, the company's org chart is designed for people, not for software engineering. See, literally everything ever written about Conway's Law and my own Conway's Law doesn't apply to rigid designs. This sounds like a very interesting article. Maybe we'll react to it later in a future episode. In DDD, we reason like this. The engineers need to build, maintain, and evolve secure and performance systems that serve the company. To do that, the engineers need an understanding of the domains and of the software systems. To achieve that, we leave the domains as the organization sees them, and we draw our own bounded context to serve our need for understanding. The bounded context exists primarily for the engineers and for the engineers' communication with domain experts and other business functions. Ideally, we look at the organization's carving up of domains and mimic it in our own drawing of bounded context. In fact, many DDD advocates have been claiming that this is the only way. There are so many counterexamples that I don't understand why people advocate it. The organization's perception of domains is never a design choice, so having our design mimic that structure can be harmful. So that's true. However, there are some forces that push us in that direction. One of them is change. Different departments change with different speeds. Another one is jargon, because sales jargon is different from HR jargon, so naturally you'd have different bounded contexts. But it doesn't mean that there's only one-to-one. So yeah. A single domain across multiple bounded contexts. Here's a nice example. An online retailer considers pricing to be one of their core domains. They have two software systems. One does web scraping to find competitors' prices for the same products, and machine learning to react to inputs such as supply and demand. The second system allows employees to price items manually, set up discounts and campaigns, do strategic pricing, and psychological pricing. The second system also has rules to pick the final price between the two systems and takes into account minimum margins. Why two systems? The programming language, tech stack, and engineering skills used for the second system are very typical of business applications, databases, user interface, domain model. The first system requires machine learning skills, which is a different specialization. Yeah. So we are talking about what I was saying, a technical cutoff. There are different technical needs. On top of that, one system was built first, the need for the second emerged later, so the need for different skills and technology as well as historic reasons are the causes of this split. I think these three are valid reasons for choosing bounded context on their own. The engineers choose their BCs to fit their needs. I feel there could be at least 4 bounded contexts. I'd separate the web scraping and machine learning into 2 BCs, bounded contexts. They are very different technical concerns. More importantly, from the DDD perspective, they have very different domain languages modeling needs, and mixing them causes more confusion than benefits. From the architectural perspectives, we'll see that the machine learning system has at least 3 inputs: the web scraper, the company's own sales data, and the supply data. It's not very flexible in current system that one of these inputs is part of its own consumer. Separating them would make it easier to add more inputs in the future. The manual pricing context stays, but I'd extract the rule-based part. The reasoning is similar. The pricing rules context takes the manual pricing, the machine learning, and the supply data as inputs. So one domain pricing from the organization perspective, 4 languages and models, and therefore 4 bounded contexts to fit the engineer's needs. Yeah. So in this case, it's basically a split based on technology and there's another force, which is software evolution. He mentioned something here where we have one of these inputs is part of its own consumer. Separating them would make it easier to add more inputs in the future. This is a very common thing. The way I usually state it is as a law of software evolution, which is one will be more. If you have one type of input for your sales computation, you can bet that eventually you'll need a second type of input, probably a third and a fourth. If you already have three, it's likely you'll have more. So it makes sense to make this split purely from a software evolution perspective. We expect this architecture to evolve in a specific way, which means we can do this cutoff. Are these actually 4 domains? Arguably, but the organization doesn't see it that way. In any case, the current system has 2 bounded contexts for 4 areas, and changing it to my proposed design with 4 bounded contexts might not be worth the effort. In that case, we'd have 2 bounded contexts for 4 domains, which again could be a valid choice. There's a more radical example of a company where one domain is not just split but repeated across 20 bounded contexts. You can find it in the book Design and Reality by Rebecca Worsbrook and me, or read it for free. This book, highly recommended. Rebecca is amazing, and they both wrote some amazing essays. So definitely read the book if you can, or read the essays for free, but it's good to support them. Here are some more examples that show value reasoning for avoiding a one-on-one mapping. Startups. A startup with no pre-existing software would theoretically be the easiest place to do a one-on-one mapping. You look at the domains the startup needs, draw the bounded context accordingly, and start building. Startups don't have the luxury of clean boundaries. You are figuring out what business you are in while building the software. That's one of the problems. So maybe you know a little bit more about the domain, maybe you know less about the domain and you are learning. If you are just learning the domain, then you need some more. So you'll jam user management into your payment system because that's where the engineers had time. You choose bounded context prematurely because you didn't understand them yet. You'll split order processing across 3 services because each was built during a different pivot. Everything is hacks and duct tape. This isn't about software design, it's survival. You're usually starved for people, skills, time, and money. You want to find the right balance between making good software design choices and doing literally anything that gets the company to a point where it gets funding or revenue. Over time, needs change, resources become available, insights grow, you can now rethink the design and draw new boundaries, presuming you can keep the code flexible enough to change it. So in the context of a startup, we're talking product discovery, we're talking market discovery, we're talking figuring out the product market fit, and until you get there, everything goes. Experiments. There is a use of bounded context that Eric Evans, who coined the concept of bounded context, talks about a lot. If you isolate a small area into bounded context, you can use it to experiment. You can try business ideas or technical ideas, learn from them without affecting the existing systems, and throw them out. Say within our pricing domain, we have an isolated bounded context for rule-based pricing that only has a small, well-defined interface with other parts. We can leave it as is and make a new rule-based pricing context. It could be designed differently, more efficiently, use different technology like a rules engine, or have a different model and language. We could A/B test it on a small part of our business using a simple switch or a feature flag to send requests to the existing bounded context or the experimental one. Then if it works, migrate, if not delete it, no risk to your existing system. This is the more general approach of parallel change. You create, when you want to change something, instead of replacing it, you create a new one, and then you make sure that the two are working similarly, at least if not exactly the same, but with different operational results, or maybe with better design, and then you remove the older one. This is a general technique. We have a video on it. Check it out. But Here, one thing I would do slightly differently is that instead of doing A/B testing, what I would do is to send requests to both of them if possible, if it's not too costly, for example, because it depends a lot on your operational cost. But ideally, you'd send requests to both of them, you'd get the results, compare the results, log when there are differences in the results, and this allows you to test this in production and make a seamless transition to the new one. That's really great. Older companies have software systems dating back years and decades. A legacy system survives because it brings more value than it costs to eat it. There's a typo. There's no way you can redesign the whole thing to fit our ideal one-on-one mapping. The redesign is hard because a lot of the knowledge of the system has disappeared. Yeah, this is one of the biggest issues with legacy systems. The knowledge is encoded. It's in the code, but it's very hard to retrieve from code. You can redesign without the knowledge. DDD and general software design recognize this. We have patterns to deal with isolating the systems that are ill understood from the newer ones. Yeah, one of the common ones is the strangler fig pattern, where you implement all the new features that should have gone into the old system, into a new system, and then basically have a check that says if this feature is implemented in old system, then send to old system. If not, send to new system. And then you can rewrite little by little the old system into the new one and move more and more of the requests to the new one. And this is one of the best ways to deal with legacy code. Any component that is easy to replace will eventually be replaced by a component that's hard to replace. Sustrik's law. I like it. In other words, a system that's old enough will be highly coupled, making it harder to isolate bounded context. Deciding what to improve, replace, or keep is a design choice that you analyze for costs and benefits. Yeah. So definitely another context. Mergers and acquisitions. I can already see where this is going. Typically in mergers and acquisitions, you have two companies operating in the same business domain or roughly in the same business domain. But they have two different sets of systems, two different sets of practices, and so on. And probably two different styles of organization. Here's where the one-on-one myth completely breaks down: mergers and acquisitions. Say our retailer from the early example buys a nearly identical competitor. All of a sudden, we have at least two bounded contexts for pricing, two product catalogs, two accounting systems, to everything. The business sees one domain each. Engineering sees a massive overlapping context that somehow need to work together. This situation might be cheaper and more effective than trying to unify everything. More realistically, we'll want to merge some and leave others. Yeah. Accounting is a very mature domain, and I imagine that merging two companies is bread and butter for them. Yes, but it depends a lot on the implementation. But you'd want to unify, indeed. But maybe the competitor has a single bounded context that handles the product catalog as well as the pricing. Perhaps one company is better at web scraping and the other is better at machine learning. Deciding what to keep or migrate away from, what to combine, what to split, what the new boundary should be, all of these are a mix of business and software design choices. You'll end up with a fascinating context map showing a patchwork of bounded contexts that overlap with multiple domains and domains that overlap with multiple bounded contexts. And the best design is the one that serves business needs and engineering needs. Yeah. In this case, I think Conway's law is also a big deal because the structure of the organization, you have two organizations, and the structure of each organization has influenced the architecture. Now you are merging them, you are creating a new structure which pushes for a new structure for the architecture. So it's one of the forces. It's not necessarily that it will win, but it is one of the forces acting on your architecture. Conclusion: stop trying to make your software mirror your organizational chart. Yeah, why do that? You are modeling software, you're not modeling organization. That has already been done. Now you can get inspired from your organization when you model your software, but it's not the only force that acts upon your architecture. The engineers, bounded contexts are design tools, not bureaucracy. Bounded context boundaries should be deliberate design choices. Yes. The engineers need to make it easy to their job so they can serve the business needs in the short and long term. As a linguistic and model boundary, bounded contexts are a great tool to achieve that. If we let ourselves be constrained by the organization's perception of its domains, we are not making design decisions. Mimicking reality or some perception of it is not our goal. See design and reality. This is a very interesting, I think that he refers to the article Design and Reality. We have a reaction to that. Check it out. Very interesting article. It shows how not only the design doesn't match one-to-one with the reality, but how software design can influence the reality later on. It's really cool. It merely satisfies a need for simple design rule for pretty system diagrams. Isolating a language and the model is incredibly productive, yes. Jargons. A right-sized bounded context allows us to isolate domain knowledge and reason about it with the model and language. They make it easier to understand the system and therefore to evolve it. We can isolate chunks of a domain for all kinds of reasons. Access to domain experts, technical expertise, security or performance. Yeah. Avoiding leaky abstraction or pollution from legacy components, business value, fast experimentation, architectural needs. In short, draw your bounded context pragmatically to get the advantage. And this is Mattias' article. I think it's very interesting, and once again I like to go back and expand on it a little bit. Whenever you are using a new technique, be wary of expecting things to be very simple and immediate. Okay? It never works. It never works like that. So I've been part and I've been a spectator, let's say, to many different trends in software architecture. Some of them were pushed by large companies, usually by Microsoft. But then, in my case at least, Microsoft did a lot of the pushing but then also Google, Facebook, and so on. The latest one that we can point to is using large language models for code, for programming. Is it a technique that can help? Yes. Is it a technique that solves all the things about software development? Absolutely not. So we need to be very careful when we adopt a new technique. And my advice, my general advice is when you try a new technique, give it a fair chance, try it out, try it out with an open mind to understand what is the applicability domain, where it shines, and where it doesn't. And then you will know precisely what technique to deploy in what context. And this is very similar here. Domain-driven design is an excellent way of structuring and modeling your architecture, but be very wary of simple ideas like mapping one-to-one. Another example I can give is from automated testing. Like a very simple way to write unit tests would be you take every method from every class and you write tests for it. Is that a good structure for your testing suite? Absolutely not. Because whenever you restructure your code, you need to restructure your tests. And that's not what you want. Ideally, you would want, when you restructure your code, the tests stay almost the same. And when you add new features in your code, you need to add new tests. And that's it. Now, this is not 100% possible. There's of course a relation and some level of coupling between the tests and your code, but you can minimize that coupling to the point where you don't need to do that. So there are many such examples of techniques where we tend to oversimplify and say, let's just go one-to-one, or let's try to apply it for everything, and then we complain that it doesn't work, and so on. Figure out what is the applicability domain, apply within that applicability domain, don't apply outside the applicability domain, and then apply it where it really shines. This is what works for every technique, including domain model. This is it for me today. What do you think about all this? Have you had issues with figuring out bounded context with domain modeling? Let us know in the comments. We are doing a series of architectural katas, performed architectural katas. One of them is recorded on this channel, and you can see it in the live section because it was live, and where we show these techniques, how they are applied and how we believe they should be applied for relatively small problems, so that you can learn by seeing experts applying techniques. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.